All right, so in this next page, what we're looking at here is actually applying what we have just talked about. So in the problem, it actually gives you what we want you to use, but you're not always going to be given the formula. You have to know it from memory. Okay, so here it says find the slope of the tangent line using this given formula. Okay, given that f of x is equal to x minus 1, okay, at x equals 2. And actually, I'm going to take this one step further. We're actually going to write the equation of the line that's tangent to the curve once we find the slope. So we're going to go one step further. So I'll show you that when we get there. So our primary purpose here is to find the slope of the tangent line. So we're going to use this right here. Okay, so what we have is the limit as h approaches 0, and I'm going to write this one more time, of f of x plus h minus f of x all over h. Okay, so we're using this specific formula right here. So when we see f of x plus h, in f of x, wherever we see an x, we will plug in x plus h first. So what we have is the limit of 1 over x plus h minus 1. So this right here goes in right there, and you have to remember to put the minus 1 in the bottom. Then it's minus f of x. The function they gave us is 1 over x minus 1, and all of this is over h as h approaches 0. Okay, before I continue, does everyone see where I got everything from? This right here goes in right here, minus 1. You have to put the whole thing in. Okay, if I were to plug in 0, let's just see what happens. Direct substitution. Even though we know, based on what I told you before, it's going to give me 0 over 0. If I use direct substitution, I plug in 0 here, I end up with 1 over x minus 1 minus 1 over x minus 1. So on the top I have 0, right? Over 0. Indeterminate. So in order for me to evaluate the limit as h approaches 0, I need this thing to go away, true? Okay, it makes the whole fraction undefined. So I need to simplify this. What method will I use to simplify? I heard it. Louder. Complex fraction. So that means I need to multiply by the least common denominator. What is our least common denominator? Okay, look at these two denominators. Are they identical, yes or no? So when they're not the same, it is the product of the two. So what is your least common denominator? That's right. X plus h minus 1 times x minus 1. It's just the product of the two. So you have x plus h minus 1 times x minus 1 over x plus h minus 1 times x minus 1. Okay, I'm going to run out of room, so I'm going here. The limit as h approaches 0. Okay. I am distributing. I'm just looking at the top. I'm distributing this whole thing here. Remember, this is essentially sitting over 1. So when I distribute to this first fraction, the x plus h minus 1s cancel, and I'm left with x minus 1. Does everyone see that? Okay, so I'm going to put an x minus 1 here. Minus. When I distribute here, what cancels? The x minus 1s, and I'm left with the quantity of x plus h minus 1 in the denominator. Guys, the whole idea is to make this thing go away. Do not distribute it, otherwise you have a huge problem. Just write it all together as a product, meaning h times x plus h minus 1 times x minus 1. Everybody okay before I continue? Okay. So we have the limit as h approaches 0. I'm going to distribute this negative. X minus 1 minus x minus h plus 1. Leave the bottom and just rewrite it. Okay. So the top looks super messy, but really this problem is designed so that things start to go away, so that I can get rid of that h in the denominator. So let's look here. I have a positive x and a negative x. What's going to happen? They're gone. They become 0. I've got a negative 1 and a positive 1. They go. So what's left in the numerator? Negative h and then I have an h in the bottom. Can I reduce those? So what does that leave me with in the numerator? Okay, nice. So we have the limit as h approaches 0, negative 1 in the top, and then I have x plus h minus 1 times x minus 1, because these are gone, right? And I'm left with that negative 1 in the top. Okay, simplified the complex fraction, got rid of all the extra stuff. What do I do now? What do I try? Direct substitution. So I only have one h here. So when I use direct substitution, I'm going to plug in 0 for h. What happens to this h? Where does it go? It's gone. It becomes 0. So that means now I don't really have this in here. So what's left in the denominator? Yeah. So we've used the limit, right? We've evaluated using direct substitution. We have negative 1 over x minus 1. Can I say squared? This is the general equation to find the slope of the tangent line to this curve. So if I asked you to find the slope of the tangent line to this curve at x equals 5, you use that formula. At x equals negative 25, use that formula. Negative 125, use that. It will work for every single point on that curve because it's specific to that function, but general for every point. Does everyone understand that? So you can use it for anything. So now what we want to do is we want to find the slope of the tangent line. This is the notation. When x is equal to 2, using negative 1 over the quantity of x minus 1 squared. Okay, the slope of the tangent line given x equals 2, and this is the equation. Okay, this is not a coefficient. It's x equals 2. This is the function. Okay, what do I do? Plug in 2. Yeah. So what this is the slope of the tangent line is equal to, let's see, 2 minus 1 is 1. 1 squared is 1. What's negative 1 over 1? Negative 1. Okay, so at x equals 2, the slope is negative 1. Is the slope going to be negative 1 when x is equal to 25? Probably not. I'd have to find out. I have to plug it in, right? Okay. Questions so far? Okay, so this is my slope. When x is equal to 2, what is the corresponding y value when x is 2? How do I find that? Plug x equals 2 in where for x? Up here, right? Okay, so that means my y value is going to be what? 1. Okay, I have a point and I have a slope. Can I write the equation of the line that's tangent to the curve when x is equal to 2? Okay, let's do it. Y minus 1 is equal to negative 1 times x minus 2. I'm done. Do I have to distribute? No. Do I have to add or subtract? No. You're done. All that for that teeny tiny little slope and that itty bitty little equation. But do you understand where I got everything from?
Where did you get y equals 1?
We took our x value and went back up here to the function that it belonged to. Yes. Mm-hmm. Yep. Okay. Any questions on that before we do the next question? Are you sure? So, am I moving too slow? No, I'm good? Okay. Well, I want to be sure. Okay. It is imperative that you understand what's going on. To me and all of those around us. Okay, so here it says use either version of the definition. No, we're going to stick with what we've been doing. Okay, let's use the same one. Let's be consistent. Agree? Yeah? Fair? Okay. So what we want to do is find the slopes of the tangent lines to this function. Okay, y is equal to the square root of x. So I'm just going to highlight this. That's our function. That's f of x. At x equals 1, 4, and 9. Okay. So remember in the previous problem I said this is the general equation for the slope of the tangent line at any point on that given curve, 1 over x minus 1. We're going to do the same thing. And then we'll find the slopes at 1, 4, and 9. You can use it for any point on that curve. Everybody ready? Okay, same thing. So we've got the limit as h approaches 0. I'm just going to write the whole thing. F of x plus h minus f of x all over h. That way I remember it. So this is equal to the limit as h approaches 0. I need to plug x plus h in here for x. So what is that going to make this first? Question. If this said f of 3, what is that telling me to do? Plug in 3 for x in here. This is x plus h. Where does this go? Into this for x. So this x is gone, and I put in the whole quantity x plus h. So it's the square root of x plus h minus, what is f of x? The square root of x. And this is all hanging out over what? Yep. Okay. Now, again, if you try direct substitution, you end up with the square root of x minus the square root of x over 0. Can't use it. So how do I fix this so that I can evaluate the limit? Perfect. Conjugate. So in this case, it is the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. So we have the limit as h approaches 0. Okay. This right here is a difference of squares. It's like x minus 2 times x plus 2, right? So that means I multiply the first two, and what does it give me? I heard it. X plus h minus, what's the square? That's right. All over, am I going to distribute anything here?
No.
Nah. H times the square root of x plus h plus the square root of x. Okay, let's look in the top. Okay? So when I look in the top, I have a positive x and a negative x. What's going to happen? See you later. Bye-bye. Okay? Here, I now have this h in the top and this h in the bottom. How does that help me? Yep, they're gone. So now I'm going to rewrite. This is the limit as h approaches 0. What's in the top?
1.
Oh. Positive or negative? I heard a negative one. It's positive. The other one was negative based on the problem. And then in the bottom, I'm left with the square root of x plus h plus the square root of x. What do I try now? Direct substitution. Okay, so that means this h is going to go to, it's going to go away, right? I plug in 0, it's gone. So this is 0. So now what am I left with? Yep, 1 over 2 square root of x, which is the formula for the slope of the tangent line. Okay, does everyone see how we got that before I continue? Okay, so now the other part of the problem is it says find the slopes of the tangent lines to this curve at x equals 1. So the slope of the tangent line when x is equal to 1 tells me plug in 1 here. What does it give me? I heard it, 1/2. The slope of the tangent line when x is equal to 4. It is 1/4. The slope of the tangent line when x is equal to 9. Okay? Now, question. Just listen to my question, and it's a yes or no. I have the general equation to find the slope. We found the slope. I have an x value. Given an x value in the original function as well as a slope, if I was asked to write the equation of a line that is tangent to the curve at x equals 9, can I do it?
Yeah.
What is the only thing that I'm missing at this very moment? The y value, and I get it by plugging x equals 9 up here, or x is equal to 4 up here, or x is equal to, it depends. Questions? Does this make sense? Okay. Let's talk about some application. I had someone ask me yesterday, I understand the algebra, I understand what we're doing. Why are we doing this? Because for those of you, especially in physics, at some point we will be applying this. This is right now the foundation for the application. Talking about a particle or something at a given position, then we will talk about this, let's just call it a particle, the particle's velocity at a specific time. But in order to do that, the relationship between the position and the velocity is that velocity is the derivative. Okay, so you need to know how to derive that and where it came from. All right, so it is important that you understand that this formula right here, which is the formula for the slope of the secant line, is the same thing as the average rate of change. So let's talk about that for just 1 second. The slope of the secant line was the line that cut through the curve, right? And I used that because it gave me 2 points so that I could find the slope. Everybody with me so far? So that means I had 2 x values, true? And essentially 2 y values given the function. But it was over an interval of time. So average rate of change or average velocity is over an interval, meaning over a period of time. Example, if I said to you, I'm going to grade your tests and I will send out your grades anywhere between 1 and 3. Okay, that means at any point in time between 1 p.m. and 3 p.m. you'll get your grade. Does that make sense? That's what this is. You don't know when it's going to happen, but it's going to be sometime between 1 and 3. Now, you guys are not happy with that because you'd prefer to know it now. Good or bad, you want to know how you did. That's kind of how we have been going. Yes, no? Instantaneous. Okay, so that's what we're talking about here. Our instantaneous rate of change is the limit as my x value is approaching a. Okay? It is the slope of the tangent line, but the problem was that I only had 1 point on the tangent line. I just told you it is the instantaneous rate of change because it is the velocity at that given moment. It is right then. I'm going to email you your grades at 2:35 p.m. 2:36, you're looking on SIS. Probably 2:35 and 12 seconds. Do you see what I'm saying? Like at that very moment. So instantaneous, which is what we want. I can't tell you how many times like people will take a quiz. What's my grade? I'm like, I'm standing right here. Okay, so it's at that very moment. Okay, so what we're used to and what we will be using more often is the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, and this is the one that you will see more often. These are the same, but this is the one that you will use. I mean, it's truly the definition of the derivative, or delta x, but you see h more often. Okay, so if I ask you to find the average velocity, you're going to see probably this notation too at some point, v sub AVE. This is average velocity. If I ask you for the average velocity, it's over a period of time. You need, it's just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This literally is algebra 1. There's just different letters here. Okay, more calculus-like. Okay? This, instantaneous, means right at that moment, t is going to be equal to some value, and you're going to find out what's going on right then, versus over a period of time. Do you guys understand the difference? Okay, so we're just going to talk about a couple examples here. All right, so here it says, for a particle whose position is time t at the given function, this is your position function. This is just like f of x. I'm giving you the function, except now it's in terms of t versus x. Okay, we want to find the average velocity. Okay, we're going to do the setup, but you can use your calculator later. So the setup for this right here, these two, the common mistake made is that people think this is a coordinate. This is not a coordinate. This is a period of time on your x-axis, and if you're given the function, which you are, you can find the corresponding y value, meaning s sub 1 and s sub 4. So this essentially is x sub 1, and this is x sub 2. So this is running along the x-axis on your graph. Okay? So what we're saying is if we're using the average velocity formula, which is right here, this would be s of 4 minus s of 1 over 4 minus 1. So this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This right here, I mean, we could do because these are whole numbers. So s of 4, how do I get that? What does that mean? Yeah, take 4, plug it into the position function. So this is what? 16 minus 1, so this is 15. 15 minus, what's s of 1? 0. Over 4 minus 1, which is 3. So what is the average velocity? 5. And there's no units here, so let's just say meters per second. Just that's how you would give it. Whatever the units of measurement would be. If it's not given to you, just write 5. So here we'll just say meters per second, because we can. Okay, so let's jump to 3. So we're going down instead of across. All I want is the setup. You can go back and do the calculation. If this is x sub 1 and this is x sub 2, what is the setup for the average velocity? Look at your template from above. I heard it a little bit louder.
S of 1.2 minus S of 1 over 1.2 minus 1.
Such perfection. I love it. See? With confidence, too. Done. Now you just have to calculate, right? Okay, let's jump over here to 4. Going directly across. What's set up for the average velocity? I'm sorry, not everybody at once. It's too loud. Can't hear you.
S2 minus S1 over 2 minus 1.
That would be for 2. So for 4.
Are we doing 4? With confidence.
With confidence you did. No doubt in my mind. You said S of 2 minus S of 1 over 2 minus 1. That is the average velocity. Perfect. So what about here?
S of 1.01 minus S of 1 over 1.01 minus 1.
Check. Okay, so then you would just calculate those using the position function. Everybody okay with average velocity?
Yes.
Okay, so instantaneous velocity, the only issue here is, I know that some of you know the shortcut to the derivative. I know you do. But this specifically says use the definition. So we're going to use the definition and we will do it together. Okay, so this is what we're going to take a look at. Instantaneous velocity, okay, at 1 second. So using the definition, okay, this is what we're going to do. We are going to find the velocity, okay, which is equal to the limit as h approaches 0. Can everyone see that? Of f of x plus h minus f of x all over h. Okay, I keep writing it because I want to know it. It will not be given to me. Okay? And when I say me, I mean you, but me, but us. Okay? So, this is what we have. We have the function. It is in terms of t. It's not a big deal. So if I wanted to rewrite this so that you guys see it in terms of t, it would just be the limit, okay, as h approaches 0, of s of t plus h, I'm just putting it in the same format, minus s of t all over h. Bless you. So that means we need to move back up here. This is my function, so I'll put it right here. S of t is equal to t squared minus 1. Okay, so what this means is I'm going to take t plus h and plug it in for t in this function. Agree? Which means I need to square the quantity. So we have the limit as h approaches 0 of t plus h squared minus 1, that's this, minus the quantity of t squared minus 1, that's s of t, and this is all over h. So I do have a little bit of algebra to do. Okay, I need to FOIL this and distribute. Okay. This right here FOILed is t squared plus 2th plus h squared minus 1, distributing, minus t squared plus 1, and this is all over h. Okay, this comes with experience and multiple times foiling. All right, so it's t squared plus 2t. I know some of the pluses look like t's. t squared plus 2th plus h squared minus 1 minus t squared plus 1. Whew. Okay, so just like before, we're looking to see what goes to 0. So I've got a positive t squared and a negative t squared. Gone, right? I have a negative 1 right here and a positive 1 right here. Gone. Bless you. Okay, now, before, there was just an h left in the top. But if you notice, you have two terms. One of them has an h and one of them has an h squared. What can I do? I can pull out an h. I can factor out an h. So I'm going to do that down here. Okay, so I've got the limit as h approaches 0. I'm going to factor out that h. So it's h times 2t plus h, because h squared divided by h is h, all over h. How does that help me? Yeah, these are gone now. Now can I try direct substitution?
Yes.
Okay, so that means this h right here will become 0 using direct substitution, right? So now what am I left with? 2t. This is the instantaneous velocity. For those of you that know the shortcut, is that the derivative of this? It is. Okay. All that's why I know you guys are like, seriously, do I really have to use it? It's so easy if I just, okay, get in time. Okay, so just please be patient. So now we need to evaluate this when t is equal to 1. So instantaneous velocity is 2, let's say, meters per second, because to be consistent. So 2 meters per second, okay? And that's v at 1, the velocity. Okay, does this make sense? It's a lot of work, I know, for a teeny tiny little 2t, but, okay? Questions?
Ooh.